You guys, and then take that for B-Day. Okay, so given this, okay, and if the lesson gets going to, oh, we have lunch, break it between lunch. I was going to say, I'll give you a break, but we'll have lunch. Okay, so we're just answering these things. What is my amplitude?
3.
And the number of cycles we're going to see on an interval 0 to 2 pi. 2, right? We just use B. This is Bx. And so B is the number of cycles from 0 to 2 pi. Our period is using the formula 2 pi divided by B. So we have 2 pi divided by 2, which is pi. So remember that period means the physical length of one cycle of, for this one sine will be over pi. And then describe the transformation in words. So we would say, yes, we would. So I'm going to write it up here if you don't mind. So we would say a stretch of 3, correct? Stretch 3, reflection over x-axis. We are going to have to be able to graph these today really well. A shift of right, what? Pi halves, very good. And a shift of down 5. Questions? Pretty easy, yes?
What do you think about that thing?
Yeah, so that will just, that just affects our, we'll just state that in shifts. Like, we could get really technical with this and call this a compression of a half, but we're not gonna, we don't need to do that, if that makes sense. So, good question. Yes. Good question. That is literally, we just find that by looking at B. So, B is what's multiplied to X. So you always just look there, that's the number of cycles from 0 to 2 pi. Yes. Good question. So we have 2x minus pi is our shift left and right, correct? So now if you were to solve for x, that would be positive pi halves, our left bound. Does that make sense? So shifted right, pi halves. Good questions. Okay, awesome. So we're going to be graphing other types of trig functions today. These ones are a little bit harder if you, to graph just because they're easier because I give you some tricks, but they're just harder to start out thinking about. Like, there's a lot to think about, if that makes sense. So last time we graphed sine and cosine. So this is what sine looks like on an interval from 0 to 2 pi. So that was with no shift. That was the parent function. And then y is equal to cosine of x, or cosine of theta, whatever. It's graphed like this. So remember that I gave you the little trick. This kind of looks like an S, and this kind of looks like a C. So if you squint your eye and tilt your head sideways, and then technically, yeah. Kind of, but it's kind of a U. But the reason I say C and S is because cosine and sine. You know what I mean, guys? Okay. All right, I want you to notice a few things. This is going to help make sense, so everybody notice a few things. When does sine of x equal 0? At 0, at pi halves, isn't that where the sine function equals 0, guys? How high up or down, right? Isn't the function of sine at 0, at pi, at 0? And where else? 2 pi. So sine of x equals 0 at 0, pi, and 2 pi, okay? Then cosine. When does cosine equal 0? Pi halves and 3 pi halves. Okay, sweet. Okay, now I want this, there's a reason I'm bringing this up. Remember back to a while back when we were graphing rational functions. Remember that when we were graphing rational functions, we know we can't divide by 0, correct? That's why we're talking about it. So we're graphing this rational function. So we know we can't divide by 0. That's an undefined place, correct, on our graph, everybody? So we would say x cannot be 2. That is true. So our x value is never going to be 2, and that's what created our vertical asymptote. Remember that? Everybody? Because look, x can never equal 2, so we have this vertical asymptote. So our graph gets close to 2, but never crosses 2. It will never be 2. Everybody understand? Okay, awesome. So we can't divide by 0. Okay, anyways, we're going to have vertical asymptotes in our graph today. Okay, so here's our first function we're going to graph, and it's tangent. So write that down. Y is equal to tangent of x is what we're graphing. So just a reminder that really when we're graphing y equals tangent of x, we're technically graphing y is equal to sine over cosine. That is what tangent is. Sine divided by cosine. So I rewrote it like this. Y is equal to sine divided by cosine. Now notice, because we're dealing with fractions, we are going to have some vertical asymptotes. Because we know we can't divide by 0, so isn't it true to say that cosine of x cannot be 0 for tangent? Everybody?
Yeah.
Understand? Okay, so we're going to have vertical asymptotes at, well, when does cosine equal 0? At, right here, right?
Yeah.
Pi halves, 3 pi halves. And then really at any time we hit those same places, same things, a vertical asymptote. So really, also we could say negative pi halves is a vertical asymptote. We can't be negative pi halves because that's when cosine 0. And then also 3 pi halves, 5 pi halves, right? Any place that hits here or here. Everybody understand? Okay, so we're going to have vertical asymptotes when graphing tangent. Okay, now I want you to look at my unit circle up here on your desk, and we're going to go through and list out some xy points the first time around so that you can see what tangent looks like, and then I'm going to teach you some tricks on how to graph it quickly. So everybody, we can always graph functions by plotting points. So everybody, let me just point out here, I'm just making an xy chart, and we can plot every single one of those points if we wanted. I just chose some pretty points, ones that come out nice and pretty. So let's start with negative pi halves. Now remember that tangent is sine over cosine, which is y divided by x, right everybody? Our y value divided by our x value is how we find tangent. Okay, so here we go. We're going to answer this. What is tangent of negative pi halves? That's negative 1 divided by 0, which is undefined. Okay, undefined. Now, negative pi fourths. The reason I chose to also plot that, which is this highlighted point, is because it's going to come out pretty. This divided by this is negative 1, correct, everybody? So there's a point on our graph. If we go to 0, that's right here, we're talking here. We'll do 0 divided by 1, which is 0. That's a pretty point to plot. And up to pi fourths. That'll be this divided by this, which is 1. And then up to pi halves. We'll do 1 divided by 0, which is undefined. Okay. Yep, where these undefined values are is where we're going to draw in with vertical asymptotes. That'll be our first step. Very good. So 3 pi fourths is a very pretty point because we'll do this divided by this, and don't we get negative 1 again? And then if we go to pi, we're going to have 0 divided by negative 1, which is 0. So then we go to 5 pi fourths, and we'll have negative square root of 2 over 2 divided by negative square root of 2 over 2. We're going to get 1. And then at 3 pi halves, isn't that the same thing as? So 3 pi halves is undefined, right? And then 7 pi fourths, negative 1. And 2 pi is 0. So what I want you to notice is a couple things here. All these values you see multiple times. So what I want you to notice is after how much amount does it start repeating? So we started undefined here, and then we went up to here, and now we're undefined again. And doesn't it start over? So this is one cycle, and isn't that pi in length? From negative pi halves to pi halves, isn't that pi in length? So our period for tangent is different than sine and cosine. A full cycle for sine and cosine is from 0 to 2 pi. But for tangent, a full cycle is simply just pi, because then we repeat. Does everybody see? Now we're repeating. After undefined, we get negative 1, 0, 1. Undefined, negative 1, 0, 1. Undefined, negative 1, 0, 1. So it's repeating every pi. So things to notice, I'm going to move this, just some things I want you to notice with tangent. It repeats after pi. So our period for tangent is pi, not 2 pi, like with sine and cosine. And notice we have vertical asymptotes whenever cosine equals 0, which makes sense. So that'll be every other quadrant, basically. All right, so let's graph those points. I just have the points written up nice and pretty over there, all in one line. So let me show you how to graph this. So what we'll do is first go through and graph our vertical asymptote. So let's start at negative pi half. And then our next vertical asymptote is over at pi halves. All right, everybody? So then let's keep it nice and pretty. So if I add pi halves again, because it looks like I'm splitting it into pi halves, if I add pi halves again, where am I going to be? Pi, correct, everybody? If I add pi halves again, so 1 pi halves, 2 pi halves, will that be 3 pi halves? 4 pi halves is, okay, and then 5 pi halves. And then we could keep going. That's good enough for me for right now. So let's put in some vertical asymptotes. So we have one at negative pi halves. We have one at pi halves. We have one at 3 pi halves, correct? And that's what we're looking at. And we would have one at 5 pi halves if we kept going. Okay, now let's plot some points in between these. So this is 0. So at 0, what was tangent at? Everybody look. 0. So we have 0, 0. Now notice something. What was pi at? 0. So in between, we're at 0. Does everybody see that? In between those asymptotes, we're always going to be at 0. That is always going to be true for tangent. Then, if we look this way, what is that? From 0 to pi halves is pi fourths. I'm not going to write that in. But right here is pi fourths. So at pi fourths, weren't we up at 1? So we'll call this 1. Okay, so we're up at 1 at pi fourths. Now, this would be negative pi fourths. And if you look at negative pi fourths, we're down at negative 1. So now what's going to happen with tangent is this is going to come up. It's going to approach our asymptote, but never cross it. It never crosses a vertical asymptote. It can cross horizontal asymptotes, but we're not dealing with that in tangent. But a function will never cross the vertical asymptote. And it comes down and follows the asymptote. So if you look at pi, what's going to happen is, right here at this value, it's going to be up at 1. At this value, in between here, it's going to be down at negative 1. And it's just increasing without bounds. So then between these two values, the 0 and the asymptote, it's going to be down at the amplitude. And between these two, it's going to be up at the amplitude. So we've drawn in a couple different cycles here. 3 to be exact. Everybody good with that? Now look at, just fun fact, just things to notice, is we said a tangent, one cycle is, one period, which means length of one cycle is pi. So look, isn't from there to there pi amount, pi distance. From here to here is pi distance, right? So it's just all making sense. Okay? Just keeps going, yeah, just keeps going. Now, interesting enough, what I want you to do is everybody go to your calculator just so you see what's happening. This is actually really cool. So, like, we know that we're graphing tangent. So, look, this is 90 degrees, correct? Pi halves is the same thing as 90 degrees. So if I say to you, we know that we can't have tangent to 90 degrees, it's undefined, but let's plug in something really, really close to 90 degrees. So instead of 90 degrees, type in tangent of 89.9. What do you get out? So that I know how high up, just so that we can see what's going on with this. So type in your calculator, just in the normal calculator, tangent of 89.9. What value do you get? 572, roughly, right? So do you see how as we get close here, it's going up really, really high? So let's type in something even closer to 90 degrees. Type in tangent of 89.999999. Close your parentheses. So that's almost 90. What do you get? Some huge A number, correct? So do you see how it's just as we approach 90 degrees, we're just getting larger and larger, right? Does that make sense, everybody? Pretty cool. That's what asymptotes do. As you approach the asymptote, your function just gets larger and larger. Okay, sweet. All right, here we go. So let's change it. Let's grab this. Now we're going to go a little bit quicker because I feel like you guys probably, I go way slower at this class than I do any of my other classes because it's the first time I teach it. And so we always like fly through it in the other classes. So that's probably why Tyler's falling asleep because I go too slow with you guys. Okay. So, first of all, a couple things to notice. We have a change of amplitude and a change of period. Everybody watching. So, our amplitude is 3, and our period, remember that, for tangent, a normal period is just pi. So now we're doing pi divided by 2. Sorry, pi divided by b. I lied. Pi divided by b. Isn't b 1/2? Everybody? So we're doing pi divided by 1/2 to find period. So that would be 2 pi. So for this particular tangent, we're going to have a full period of 2 pi. Now I always just choose to use algebra to find my new asymptotes. So what I do is I go up here off to the side and I say, I'm just going to set x over 2 equal to where the asymptotes used to be, the original asymptotes. So weren't our original asymptotes at negative pi over 2? That was my left asymptote, one of them. We can do many asymptotes. One of my right asymptotes was pi halves. So x over 2 equals pi halves. Now there's others that we could go through and find, but I'm just going to go with those two to find my new left asymptote, my new right asymptote. Solve for x. So we'd multiply both sides by 2. So x is equal to, guys, algebra. Multiply by 2, multiply by 2. Oh, okay. Okay, so my left asymptote is going to be at negative pi, and my multiply by 2, multiply by 2. My right asymptote is going to be at positive pi. So what I'm going to do is first go and draw that in. So negative pi and pi, those are going to be the first cycle I draw in. Now let's see why that makes sense. Isn't this a full period, a full cycle? For this one we said was 2 pi, correct? Isn't that distance from there to there 2 pi, everybody? Split evenly, right? So let's go another, we could go over here, we could do more algebra, but let's just go, from here to here is going to be another 2 pi's. So pi plus 2 pi will put me at 3 pi. So let's put in another cycle, because we need to at least draw 2 cycles. Let's do one more, just for kicks and giggles. So that will put me at, you add 2 pi, will put me at 5 pi. Okay, now we know that how this is going to work. So halfway between, let's just at least put those in. So this would be 0. Halfway between here is 2 pi. Halfway between here is 4 pi. Okay, so how tangent is going to work is, it's going to start in the middle at 0. It's going to start at the middle. It's going to start at the middle. And then our amplitude for this one's 3. So up 1, 2, 3. It's going to go up here, boom, at 3. And then from here over here, it's going to go down 3. So this will be halfway between here. It's going to be up at the amplitude. Halfway between here, it'll be down at the amplitude. Halfway here, up at the amplitude. Halfway here, down at the amplitude. So we drew in 3 cycles for this tangent function. Questions? Yes. Okay, good question. So if it was non-shifted tangent, we know that we're talking about sine of x over cosine of x, right? So we said in the original non-shifted function, cosine of x can't be 0, correct? So our vertical asymptotes came from when cosine did equal 0 in the original function, which was at which values on the unit circle? At negative pi halves, right? Let me scroll back to my unit circle. Right, wasn't it? So we said, let's see what slide I was saying. So we said that cosine of x cannot be 0. So we have vertical asymptotes wherever it does equal 0, which was at 3 pi halves and pi halves, correct? Isn't that when the x is 0, the only place? So isn't it also true that it's negative pi halves? It can equal negative pi halves. So with cosine, if I'm ever dealing with that, I just start with that one because to draw in a full cycle, that would be from negative pi halves to pi halves. Does that make sense? Halfway around the circle. From negative pi halves to pi halves. Does that make sense? That's one cycle of tangent. Can you, so let me say that again. So this was just tangent. So do you see how our original asymptotes were at these values? So we just did algebra. So now we changed this. This was x over 2. So we did some algebra. We said our original asymptote was at negative pi over 2. So we did some algebra. X over 2 equals negative pi halves. And then we could just go through and use algebra to solve for our new left asymptote. I do, yes. We didn't have to, but I always do because then that's my first cycle. So we could have started with pi halves and 3 pi halves, you know what I mean? Good question, yeah.
I'm wondering, why is the bottom and top of the asymptote? Oh, because
we just calculated these, so see how in between those values, the 0 and the asymptote, it was down at the amplitude. That's just how tangent works. Okay. All right, is everybody okay with tangent for the most part? Yes. Yes. Okay, one more for tangent for safekeepings. Or are we too bored and you look a little tired. Do we need to take everyone stand up and move? Okay, do that. Really. So, first of all, we would say, okay, we're dealing with tangent, which is, once again, sine over cosine. So we know that cosine of x cannot be 0. So our original non-shifted function has vertical asymptotes at x equals negative pi halves, x equals pi halves. There's more of them. X equals 3 pi halves, also correct. We could list out all the places. We could keep listing these out. Okay, so now we're dealing with 3x. So we're going to find our new asymptotes by going, okay, 3x equals the original asymptote, so we can just use some algebra. So 3x equals pi halves. I'm just going to start out with those two. So let's solve for x. Now let's think advancedly here. We're dividing 3, but let's really just think of it like this. Let's multiply both sides by 1/3. Isn't that good? So we're going to multiply both sides by 1/3. So then x equals negative pi 6 is going to be our left asymptote. We're going to multiply both sides by 1/3. So our right asymptote will be at positive pi over 6. So that's when I like to start with tangent, is my left and right asymptote, one of the left and right asymptotes. So we're back here at negative pi 6. We're up here at positive pi 6. Okay, now those are asymptotes. Ding, 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 ding. Okay, now one more thing. We can keep going. We can find more asymptotes by just keep doing this. Or we could say, okay, what's my period, which is pi divided by 3, correct? Pi divided by b isn't b3, everybody. So it makes sense because look, this is one cycle right here. And isn't that unit, since it's split evenly, it's that full thing is pi thirds. Do you see how that would be negative pi 6 and positive pi 6? Split evenly. So think about it. To get to the next, to go another period, because we need to at least graph 2, won't we just add pi thirds to pi 6 to put me where I am when I do that? Okay, we'll do that, and we get pi halves, I believe. Do we? Yeah. So this will put us at pi halves. So then I draw in another vertical asymptote, and let's just draw in 2 for this one. Okay, sweet. Questions? Yeah, because and then I could keep going. I could add pi thirds again and draw in another. So I could add pi thirds and draw in another one, wherever that'll put me, because I'm not going to write it down. Pi thirds plus pi halves. We did some algebra. So remember, to find the period, you do pi divided by b. Pi divided by 3 is pi thirds. Right? Isn't b what's in front of x? Does that make sense? Yes. So period means length of one cycle, which you know. To find the period for tangent, you use the formula. Instead of 2 pi over b, tangent is pi over b. So we took pi, we divided by b, which was 3, and we get pi thirds. Questions? Other questions? These are all good questions. Okay, so let's draw in. We know we draw in halfway between. So we will want to label this. So you'll do pi half plus pi 6 divided by 2 to find the in-between point. Will you guys just get a calculator out and everybody participate and give me these values? Because you guys, we go grammar slow with you guys because you're the worst staff. Pi half plus pi 6 divided by 2 to give me the distance between that. You're right. And then we already have 0. Okay, sweet. Now, what's going to happen here is it's going to cross in the middle, being at 0. And then for tangent, so our amplitude's up 1, so 1 and negative 1. So from there, it's going to be, on this side, it's going to be up here at 1. On this side, it's going to be at negative 1. We know that's how it's worked for all of tangents. Halfway between, it will be up at the amplitude. Halfway between the 0 and the asymptote, it'll be down at the amplitude. All right, so now halfway between the 0 and the amplitude is going to be down at the the 0 and the asymptote is going to be down at the amplitude. Halfway between the 0 and asymptote, it'll be up at the amplitude. So I just want you to notice all of the tangents we've drawn, none of them have been reflected, and then they've all been increasing. So that's one thing to note, is tangent is increasing from left to right. You got to remember that. This cotangent looks just like tangent, except we're decreasing. You got to remember that tangent's the one that's increasing. Okay? Are we all good? Okay, let's move on to graphing cotangent. Oh, we don't need to do this one, or we do? So if we put a negative 1 in front, or a negative, that's a reflection over the x-axis, correct? So instead of this point being up here, it would have been down here. And instead of this point being down here, it would have been up here. Isn't that reflecting those points over the x-axis? So then this would reflect over itself, so this would now look like this instead. Which would then be a cotangent function, but we'll get into that. So that would just make it decreasing, okay? Yep, okay, we won't graph that one then. Okay. Cotangent, so write this down. Cotangent of x is really y is equal to cosine over sine. Instead of sine over cosine like tangent, cotangent is cosine divided by sine. So we can't divide by 0, so it is true to say that sine of x cannot be 0. So that will create vertical asymptotes whenever sine, the value of sine, which is our y values, whenever our y values are 0 on the unit circle is going to be where our vertical asymptotes are. So I've starred those places. Everybody see on the unit circle the blue stars? That's where our vertical asymptotes come from, when sine is 0. So at 0, pi, at 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, right? Isn't also, like anytime we hit those values, so isn't also negative pi a vertical asymptote? And negative 2 pi, okay, awesome. So, the reason I write down 0 and pi is because that's my first, remember that period, cotangent repeats after pi amount of time goes by. So it starts repeating halfway around the unit circle. So, for this, my vertical asymptotes start from 0 and go to pi. That's just where I usually start. But we can use any others that we want. So everybody, I just highlighted once again the pretty points. So at 0, what is cotangent? So it's cotangent, I'm going to write this down. This is x divided by y, correct everybody? So this one's undefined, right? We just decided that. So undefined, at pi fourths, highlighted, we would do x divided by y, won't it be 1? And at pi halves, we're going to have 0 divided by 1, which is 0. At 3 pi fourths, we'll have -1. And at pi, yep, undefined. And we've just done a full cycle, right? And it starts over. Okay. So then it starts over, so we already know what's going to happen next. A 1, a 0, -1, right? 1, 0, -1. And at 2 pi, it is undefined again. So graphing cotangent here. First thing I do when graphing cotangent is draw in my asymptotes, which are at 0 and pi, because that's when sine, because sine's on bottom, that's when sine is 0. So 0 is my first vertical asymptote. My next vertical asymptote is at pi. So I'm going to go over here and put a pi. Ding, 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 ding. Let's try one more. My next vertical asymptote was at 2 pi, correct? We could go this way as well if we wanted, so that would be -pi. Okay, so then halfway between is pi halves. Halfway between is 1 pi halves, 2 pi halves, so 3 pi halves. Halfway between this is -pi halves. Now let's actually plot these points the first time around, and then you'll notice that the pattern is the exact same way for tangent. So then after that, we'll just use our little knowledge of what cotangent looks like. So at let's start here. So at pi halves, what was my function at? 0. At 3 pi halves, my function is at 0. So do you see how in between we're ending up at the zeros? Just like with tangent, everybody. Now we know that this is really 1 pi fourths right here. So look at pi fourths. Weren't we up at 1? So we'll call that 1. And then look at right here is 3 pi fourths. And at 3 pi fourths, we're down at -1. So we'll call this. So it is literally looks exactly like tangent, except it's just decreasing instead. Does that make sense? So over here between the 0 and this asymptote, we're going to be up here at the amplitude. Between the 0 and the asymptote will be at the bottom of the amplitude. And you can go through and find those exact values if you want, but noticing these things just helps you graph things quicker. So between here is the 0, then we'll be seeing. We can draw in as many cycles as we want. Yeah. Right next to each other. So just notice, so I want you to notice some things. There's tangent, there's cotangent. So notice some things here. For tangent, that's sine over cosine. We have vertical asymptotes whenever cosine equals 0, which is -pi halves, 3 pi halves, and so on, right, everybody? So cotangent is cosine over sine. We have vertical asymptotes when sine equals 0, which is at 0, pi, 2 pi, -pi halves, and so on. Notice they look exactly the same. It's just tangent is increasing from left to right, and cotangent is decreasing from left to right. Okay? Sweet. And then they all have period, which means the physical length of one cycle is pi. 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 Okay, we get the picture. Here we go, graphing cotangent. So the first thing I do is say, remind myself, what is cotangent? So cotangent is cosine over sine, right? So we know that sine of x cannot be 0. So where were the original vertical asymptotes at? X equals 0 and x equals pi. Correct, everybody? So now I'm going to find my new vertical asymptotes because there's a 2 in front of x. So that changes our period, so it's going to change our vertical asymptotes. So we'll just do some algebra. Set 2x equal to the original asymptote and set 2x equal to the original asymptote for the right asymptote. Solve for x. So x equals, divide by 2. 0 divided by 2 is 0. Divide by 2. So x is equal to pi halves, correct? So that's where I like to start. I go and draw in my first vertical asymptote. So one of them is at 0, and the next one is over at pi halves. Okay, so Now let's figure out the length of one cycle, which we can tell right here is pi halves, correct? Or we could use the formula, pi divided by d. So that's pi divided by 2. So this length from here to here is pi halves. So where's my next vertical asymptote going to be? Pi halves plus pi halves is pi. Let's draw in another one. Let's do a few. Now, pi halves plus pi, because the length will be another pi halves units. Where's that going to put me at here? 3 pi halves. Very good. So I graphed my vertical asymptotes. That's where I start. And I just use algebra to start out, and then I put in a few. Okay, then the next thing I do is say, what's my amplitude? It's 2. So I go to the, right here, I go up 1, 2, and down 2. And then we just know how cotangent's going to work. We're going to have values. It's going to hit the 0 halfway between. So we will want to put those values in. So this will be pi fourths. This will be 3 pi fourths. And 5 pi fourths. At least just put in those values. And now we can graph cotangent. So then you have to remember, cotangent is decreasing from left to right. So we do have, the zeros are in the middle. And then cotangent, instead of increasing like tangent, it's decreasing. So on this side, we're going to go up to the amplitude. And on this side, we'll go down to the amplitude. So on this side, we'll go up to the amplitude. On this side, down to the amplitude. So we've drawn in 3 cycles there. All right. Hopefully it's not so hard that we all are stuck in school and then you have to learn math the rest of the night.
How do you know it's coming?
Plan. So now we're going to be graphing cosecant and secant, and then we'll be able to graph anything I give you. Sine, cosine, tangent, cosecant, and secant. So let's focus on y equals cosecant of x first. Once again, just a reminder what cosecant of x means. It's not the inverse. It means the reciprocal of sine. So 1 over sine of x is what we're technically looking at. So once again, because we have a sine of x on the bottom of a fraction, there is going to be vertical asymptotes because we cannot divide by 0. So sine of x cannot be 0. So we're going to have vertical asymptotes at 0, pi, and anywhere that we're landing in that same spot of 0 or pi. So 2 pi, for example, negative pi, 3 pi, and so on. Everybody understands that, correct? So I'm just going to show you, I'm going to start out showing you how we always, will make our life easier when graphing cosecant. So what we're going to do whenever we're graphing cosecant is we're just going to first of all graph sine. So y is equal to sine of x is what we're going to graph first. So everybody, we're going to graph 2 cycles and then we'll go back and do some points for cosecant here. So we'll go over starting at 0 because it's non-shifted. We're just graphing sine of x. Go over 1, 2, 3, 4. And we put a 2 pi, correct? Over 1, let's graph 2 cycles. 1, 2, 3, 4. That'll put us at 4 pi. I'm going to scroll up for a second and then we'll go back. So then this is pi, pi halves, 3 pi halves. Seven pi halves. So, okay, so let's graph in, and we're graphing y equals sine of x. I'm just going to write it. So amplitude of 1 and negative 1. 1 and negative 1. Now I'm going to switch colors here. So remember that sine starts at 0, bounces up, down, back to 0. So we start at 0. The next point will be at the max. The next point, the 0. The next point, the min. The next point, the 0. Let's do another cycle. So amplitude up, 0, amplitude down, and then back to 0. Now I'm not going to draw it in fully. I'm going to do kind of like a dotted because we're not graphing sine, we're graphing cosecant. So I'm just going to draw a dotted because we actually technically won't have this drawn if we were to draw, like we'll not have this. This is just pretend there. Okay, now that we've graphed sine, we know that we're really graphing cosecant. And we know that we have some asymptotes. So we'll go add those in a second. Let's figure out some points that we're going to graph on cosecant first. So pi force. Well, remember that it really just means 1 divided by sine. And remember that sine is our y values. So everybody go to pi force with me. Boom, boom. Pi force isn't a pretty point, but I'm trying to show you what's happening with cosecant. So if you think about what the reciprocal of sine, cosecant is the reciprocal of sine. So we're looking at this and we're doing the reciprocal, right? Everybody? Or we could do the algebra, 1 divided by the square root of 2 over 2. Won't you just flip it? So this is 2 over the square root of 2. Now I want a decimal, so just because it's easier to graph decimals. So calculate that. 2 divided by the square root of 2. What is it? Roughly. 1.4. Sweet. Now let's go find what cosecant is at pi half. So go to pi half. Cosecant is 1 divided by 1, right? Which is 1. And then go to 3 pi fourths, which is that. So it's the same thing. It'll be this 2 over the square root of 2, which is 1.4. And then go to pi. So we'll do 1 divided by 0, which is undefined, right? Okay, so we have asymptotes. So now let's go draw this in. So we know that sine cannot be 0. So that happens at 0. That's where the sign is 0, correct? Look right here. You can tell from the graph. Do you see where it's hitting 0, everybody? Sine? Can't be that. Can't be 0. So we're going to put an asymptote every time it crosses the x-axis because that's where the sine, look at it, sine, that is where sine's 0. So we're drawing in vertical asymptotes. Okay, so now let's graph cosecant. Does everybody understand the vertical asymptotes part and how it makes sense? Okay, so once again, it's wherever it crosses the x-axis because that's where our sine function, the blue thing, is at 0. Okay, now we're going to graph cosecant. So we have those points. Sorry, it's like so much information. So now I'm going to go to orange. We'll graph cosecant in orange. So at pi halves, at pi fourths, which is between these 2 points, aren't we up at 1.4? So we're up here like up here. 1.4. Then at pi halves, we're up at 1. Then at 3 pi fourths, which is going to be in between here, we're up at 1.4. So this is what cosecant is looking like. It's coming up and approaching those asymptotes. So notice our hill became a valley. So right over here, it's going to do the same thing. In the middle, it's going to hit where sine hit, but now it's going to be, instead of this, it's going to flip down and go like this. It's the reciprocal. Hills become valleys. Everybody seeing it? So over here, it's going to be at the amplitude, and then the hill becomes a valley. So the orange thing is what you would see, and only the orange thing. Cool. Ooh, ah, like fireworks. Okay. Everybody good? We'll practice one more with some changes, and then we'll move on. So, paying attention here. We're graphing, so we're looking at cosecant, which we know is 1 over sine. So what we're literally going to do, first step, is to literally just graph y is equal to 2 sine of x plus pi fourths. So, amplitude is 2, negative 2. Now it's shifted. This one's a little bit harder because we're shifted left pi fourths, correct? So if it was non-shifted, isn't sine, we could do some algebra. We could say x plus pi fourths equals 0, and then solve for x to see where our new left point is. So negative pi fourths, so x equals negative pi fourths will be our starting point. And then we can set x plus pi fourths. If it was non-shifted, a sine period ends after 2 pi. So now we'll subtract pi fourths, and we get x is equal to 7 pi fourths. So we're shifting, instead of starting at 0, we're shifting back pi fourths. So write negative pi fourths. And now we have to draw in 2 cycles of sine. So we're going to go over 1 from there's our starting point, right? Then we have to go 4 more tick marks to make 1 cycle. 4 quadrants. So over 1, 2, 3, 4, and we said that puts us at 7 pi fourths. Now we have to draw in 2 cycles, so 1, 2, 3, 4. Where's that going to put me at? Can anyone tell me? That's the hardest part for people. I want to be 15 pi fourths. Okay. Let's say you had no idea how to do that. Let's use some logic. If it was non-shifted, wouldn't it have ended at 4 pi? And then can't we just subtract pi fourths, get a common denominator, and it's 15 pi fourths. Does everybody see how we could do this? Yeah? Okay, so what's this point? This one's a little bit harder. I literally just went through and did algebra. So originally sine was started at 0, then we did pi halves, then 3 pi halves, then pi, right? Then 2 pi. So I just subtracted pi fourths from all of those to see where I ended up. Just because I thought that was a little bit easier, but there's many ways to do it. So that would put me at negative pi fourths, awesome. And then this one will be, the next one is pi fourths. The next one, this one is 5 pi fourths. And then we could find the halfway distance between those two and get here and keep going. So that's good enough for the most part. So now we're graphing sine with an amplitude of 2. So I'm going to go ahead and do it in pink. Is everybody caught up to me mentally before I graph sine? Yes. Seriously? Yes. Good. All right, so now remember that sine looks like this. It's not reflected, so it starts at the 0, right? Guys? Yeah. Then at the next point, which is here, it's up at the amplitude. Then the next point is at the 0. The next point is at the bottom of the amplitude and 0. Next point is at the top of the amplitude, the 0. This point is at the bottom of the amplitude and back to 0. And then I'm only drawing in it dotted because remember, it's really technically not there. We're graphing cosecant. Because we're graphing cosecant, not sine. This just helps us graph cosecant easy. Because remember, hills turn into valleys. That's what we'd actually be graphing. So once again, in this one, the only thing that would be seen on a graph is the orange pieces. The cosecant, not the sine. Does that make sense? It just helps us. Yeah, it's a reciprocal. Okay, sweet. So now let's go put in our asymptotes, our horizontal asymptotes. So let's do those in purple. So much going on in here. Now remember, it's when the sine function equals 0. So looking at this, right, here's our sine function. Isn't it equaling 0 at all the x-intercepts? Isn't that one up in, okay, so let's put in ding, 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 ding. And then the hills become valleys. The hills become valleys. Nope. The hills become valleys. Yeah. Everybody feeling good about that? Pretty easy, right? Literally all you have to do is graph sine, put in your asymptotes at the x-intercepts, hills become valleys.
So like, what is your 4 pi minus 4?
Because this was a shifted sine function. Then that shifted left pi fourths. Yeah. So we drew in a shifted sine function, we shifted back pi fourths, and then drew in our sine function. Okay. Okay, any other questions? Okay, let's do secant. But most people think that graphing cosecant and secant are the easiest. So all you have to do is be able to graph sine correctly, graph cosine correctly, hills become valleys. Okay, so secant of x is really 1 over cosine. So we can't divide by 0, so cosine of x cannot be 0. So we're going to have vertical asymptotes at negative pi halves, and pi halves, and 3 pi halves, and 5 pi halves, and so on. Anywhere that it crosses the x-axis. So that would be when our cosine function equals 0. Okay, so what we do to graph secant is we literally just graph y is equal to cosine of x because it helps us graph it. So we're going to draw 2 cycles in. So we start amplitude 1, down 1, and then over 1, 2, 3, 4 puts us at 2 pi. Over 1, 2, 3, 4 puts us at 4 pi. Yeah, for cosine, right? This one, so this one has no shifts. It's the basic parent function. So yeah, this is 2 pi divided by 1, which is 2 pi. So we're just going back to what we learned last time. Yeah, as you can tell, it starts to get, like mine are written so small. Okay, so now what you're going to do is just literally draw in cosine. I'll do it in pink. So remember that cosine starts at the top, goes down, back up to the top. So top through 0, the bottom, 0, top. So top of the amplitude. The next point will be at the 0. The next point will be at the bottom of the amplitude. The next point through the 0. The next point to the top of the amplitude. Continuing our next cycle, it will be at the 0, the bottom of the amplitude, the 0, the top of the amplitude. So, only draw it in dotted because it's really not there. We're not graphing cosine. It just helps us graph secant. So now we're going to put in our vertical asymptotes. That's whenever cosine is 0. Whenever that cosine function is 0, which is always right there at the x-intercept because that's when the function is 0. So we'll go like this and put in our vertical asymptote. And then, literally, all secant will do is the hills will become valleys. It will be the reciprocal. So that will come up. That will come down. Whenever this pink thing equals 0, which isn't that always right here? Isn't that where the function, how high up or down is that? 0. How high up or down is the function right there? 0. So that's where they go. Because we know that we can't have our function ever be 0 for cosine. Awesome, good questions. Oh, better just draw that or else it's gonna bug me. Okay, what a beautiful thing. Not too bad. Okay, this is my last example. So then the rest of the time is yours.
Wait.
Do you want me to go back?
Yeah.
Okay. Uh-huh.
So it's not like the how do you know where the points are?
So this point is the highest point, right?
Yeah.
This will be the lowest point, and then it just goes up. So see how that looks like a parabola kind of going down this way?
Yeah.
It'll just flip it, reciprocate it. So now it's going up this way.
Like the ones that were flipped it where it was
Well, look, here's the point, right? The lowest point. It doesn't flip over the x-axis. It's not a reflection. It goes down like this. So see how this one turned and went up? This is the down, the hill becomes the valley. So you don't find what? No. I'm looking for a rough-ish. This is as technical as we need to get. Oh no, we don't have to find these exact points. Yeah, no, we're drawing rough sketches. I'm gonna look to make sure that these end up in the right spot. That point, you know what I mean? Those points, and then the rest is all history. Okay, here we go. Secant of 2x. So what do you say to yourself? Well, secant is really 1 over cosine of x. And then you say to yourself, okay, so let's just graph cosine to help us. So y is equal to cosine of 2x is what we're going to graph first. So you need to remember we're going to draw in 2 cycles here. So my amplitude is 1. So we go over here, up 1, down 1. And then our period is 2 pi divided by b for cosine. So 2 pi divided by 2. So 1 full cycle, 1 period is pi. So we go over 1, 2, 3, 4 pi. Over 1, 2, 3, 4 is 2 pi. Halfway between puts me at pi halves. Halfway between puts me at 3 pi. Halfway between these two is pi fourths. 1 pi fourths, 2 pi fourths, 3 pi fourths. 4 pi fourths, 5 pi fourths. 6 pi fourths, 7 pi fourths. Now we're just drawing in cosine. So it starts at the top of the amplitude. Cosine looks like this. Yes? You're right. 3 pi halves, right? Good fix. No. Yeah. Okay. What? 3 pi 4. Oh, no. I just messed up on the point. So our period is pi, so I went over 1, 2, 3, 4, and that was pi, right? Yeah. So I cut it in half, pi half. This is 2 pi. So 1 pi plus 2 is 3. That was 3 pi half. Yeah. Okay, so right here was 3 pi halves and 7 pi fourths. Okay, sweet. Now let's draw in cosine. Starts at the top, the 0, the bottom of the amplitude, the 0, the top. The 0, the bottom, the 0, the top. So then, ding, 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 ding. Okay, then we know that cosine can't be 0. So if you look at where your function is 0, that's at the x-intercepts. You're right, I need to do the ding, ding, dings, which is not the same. And then, from there, hills become valleys. So it's going to be ding, ding. Valley just comes out naturally. Ding, ding. Like if I don't do that, it feels like something's wrong. Ding, ding, for reals. Like, see, it just... It does. All right, that is everything. So don't make it harder than it is. There's the problem. Ready, set, go.